Hi, I'm Eileen Farnood, and welcome back to another episode of the Plastic Shift podcast. Today I'm lucky enough to be joined by two guests. Huiyi Zhang is a PhD student at the Environmental Research Institute in the University of the Highlands and Islands. His research interest is how to use marine plastic wastes as absorbents for removing pollutants in the aquatic system. Dr. Sabolc Pap is currently a Post-doctoral Research Associate at the Environmental Research Institute at the University of the Highlands and Islands as well. He holds a wide range of interdisciplinary research interests, but mainly focuses on absorption technology in water and wastewater treatment within the principles of a circular economy and knowledge transfer between lab scale and industry in water treatment. Thank you so much to both of you for joining me today. Just to jump right into things, could you briefly explain your research regarding the potential uses of plastic as an absorbent in aquatic environments?
Yes. As we all know, marine plastic pollution is a very serious problem at the moment to threaten our marine ecosystem. And currently, there's no effective way to solve the problem. On the other hand, the wastewater treatment technologies have met some challenges in terms of cost, emerging contaminants, and the large volume of water. Also, adsorption have been confirmed. It's a very effective way to remove the contaminants in water system. So it is necessary to develop some new adsorbents, especially low-cost adsorbents, to improve the processing capacity for water or wastewater treatment plants. The reason we would like to pick up marine plastic as a candidate for developing a new adsorbent is currently there are some research indicated that we found some pollutants can attach to the surface of marine plastic in the ocean system. So the aim of our research is to solve two contractable problems together. The first one is find a way to reuse the marine plastic waste. And second is to develop a new adsorbent based on the marine plastic waste. So in order to achieve these goals, we would like to pick up several target contaminants, for example, two heavy metals and two organic compounds that represent a bigger group. And we would like to test the adsorption capacity of this compound for the marine plastic. And then we would like to improve the adsorption capacity.
Mm-hmm. Dr. Pap, anything to add there?
Yeah, I just want to say that the Environmental Research Institute has a really long history about the research about research of waste plastic and plastic pollution in the oceans and in a marine environment. We are just located in the north of Scotland. That means the North Sea and the Atlantic Ocean is all around us. That means we are witnesses as what's happening in the ocean and how is this pollution is affecting our life. That was a reason why the whole institution has started this type of research many years ago. And after all, the European Social Fund is actually find this idea of repurposing marine plastic in a different way. Quite interested and start to fund this research at the Institute.
Yeah, that's great. With regards to your research, what have you found specifically? How do plastic absorbents compare to some of the current absorbents that we're using in wastewater treatment, like activated carbon, for example? Have you found it really effective?
Well, generally, the adsorption capacity of plastic adsorbent is lower than the current popular adsorbents. The primary reason for that is the surface area, pore size, and pore volume is smaller than the current popular adsorbents. However, there is another very important factor that can influence the adsorption capacity significantly, is the surface chemistry. So because of the erosion and weathering in the ocean system, there are lots of functional groups can be formed on the surface of marine plastic. And also there are some contaminants have been found that have higher affinity naturally to the marine plastic than the other material. So the affinity is there. Our job is to try to magnify the affinity. We do not create something new, but we would like to magnify the affinity. But even in this way, the adsorption capacity is still lower than the current commercial adsorbents. So our idea is not to use this adsorbent alone, but we would like to combine the plastic adsorbent with the current ones, so that maybe we can improve the removal efficiency, or maybe we can extend the lifetime of the current one, or maybe we can remove something that the current one can't remove. Sorry.
Mm-hmm.
Yeah, it's the main point. And the main point in the about Huiyi's answer is then we are quite realistic. Then plastic from the ocean will never reach that efficiency and performance what we have with the commercial activated carbon. But yes, if we use this affinity, what is naturally there, and we can magnify it, and after we can combine with some at the wastewater treatment plants with some existing technologies, example activated carbon filtration, then we can use it and on a really good way, and we can help a lot to solve many problems.
Mm-hmm. And more specifically, like for these absorbents, what types of plastics have you been using? Like, have you found that there's a particular type of plastic which acts as a better absorbent, or is it more just like plastics in general that could be used for wastewater treatment?
Well, I think the most common plastic waste found in the beaches in North Scotland is the fish net, the ropes that used in the fishery industry, and most of them they are polypropylene, PP plastic.
Mm-hmm. So you're taking the plastic from these ropes and testing their absorbent properties?
Yes, exactly.
I see. All right. Well, in your paper, you mentioned that like more research should be done to determine whether the use of plastic as adsorbents is actually viable. So are there any particular aspects of that idea that you are the most concerned about going forward?
Yes, as I said before, that the most important thing is the adsorption capacity, because the adsorption capacity for plastic adsorbent is lower than the others. So how we can improve the capacity, or what kind of pollutants have higher affinity to plastic? Those are the questions that we would like to answer in the research. We would like to see, like for in our project, if the raw material is the plastic waste just directly collect from the beaches without any modification. If this kind of material can absorb our target compounds. If it can absorb, then we just use it as a raw material. If it can't, then we will find a method to improve the adsorption capacity. And those methods must be very environmental friendly and easy to apply. The second thing is to develop a new adsorbent, it requires a long time. So there are basically 4 stages for the development. They are lab scale, pilot scale, full scale, and industrial scale. So currently we are at a very initial stage, which is the lab scale. In the future, maybe we will have some opportunity to work with some company who is interested in this plastic-based adsorbent to do some pilot experiment. And the third thing is, I think we need more variable techniques for collecting the plastic in the ocean. So currently, the plastic waste on the beaches are normally collected by the volunteers. Maybe we can encourage more people to join this kind of activity. And for the marine plastic, I saw some news that the fishermen are now encouraged to collect the plastic waste by installing nets behind their boats, so that they can collect the plastic waste during the fishing activity.
It's a really important thing to highlight. This is the first thing what we should to say is, now plastic in the ocean is just a waste for everybody, and only people and maybe some companies dealing with this issue on a good will. Unfortunately the world is not, it's like place that mean who is like, well, I want to say then this approach, what we want to promote is some type of, to put some economical driving force in the whole circle. That means if people, if the companies seeing as a plastic in the ocean as a value, not only a waste, then maybe we can encourage and increase the removal of these of plastic from the ocean, because now they're taking off the plastic from the ocean, and then they need to process. That means there is a cost to take out and after cost to process. But if we can offer the solution that take out the plastic from the ocean, and then we have a technology when you can make from that waste some valuable product, as example adsorbent, plus you're treating water, that means there will be a money. And unfortunately in this world, always money talking. That means if we're giving some reason, there is some economical value behind the problem, then I hope then it will be forced many companies in the world, not just the ocean cleanup and these projects, or is right now is going on, to take seriously into account, like, we need to remove because we're doing good for the environment, and plus we will have some beneficial from that.
Mm-hmm. Yeah, I think that's definitely a really important point. Just to go back to what Huiyi was saying earlier, like you mentioned that there were particular methods that you could use to increase absorption rate in plastics if you found that they didn't have as high of an absorption rate. So could you briefly describe like what these methods are and if you've already done any research in this area?
Yes, I use some method to treat the plastic. Basically, those are some acid or amine reagent that you use that to treat the plastic. So the idea is either we can increase a little bit about the surface area or pore size or pore volume, or we can have some more functional groups on the surface of plastic.
Mm-hmm. Yeah, I think it will be definitely interesting to see if, especially as the research progresses, if this becomes a solution that we can actually implement. And then going back to what Dr. Pap was saying about how it's really important to encourage people to be cleaning up the oceans, do you think that we would be able to implement this usage of recycled plastics as adsorbents on a wide scale? And if we were to be able to implement it on a wide scale, how much of an impact do you think this would have on the plastic pollution problem? Like, would it take a significant portion of plastics out of our ocean, or do you think it would only make a dent just because the problem's already so big?
So I think it is certainly possible to implement this adsorbent in a large scale.
I think that what Huiyi is mentioning before, then these 4 steps in every research and innovation, then you have first in a lab scale, and then you have a pilot scale, and so on. That means we are really, as a part of University of Highlands and Islands, the research institute is really have a really good connections with example Scottish Water, where is our main body for innovation in the water treatment technologies area, and we have a dozen of good connections with private and public-private companies who's dealing with wastewater and water treatment, and we are really hoping that then when we will pass the lab scale within this PhD, when we will have already material and it will be proven that it's working well in the lab scale, then we will have some financial support from some company to move on a pilot scale and test our new adsorbents in a real life environment. I think then we are in a good place because, example, we also dealing with phosphorus removal, and there was from water, and we also had some good support from the private sector and companies to move on and actually test our sorbents in a bigger scale.
Mm-hmm. How long do you think it will take to go through these 4 stages to reach the implementation part?
It's depending how you promoting your research and actually how your research is what will be the results from the research, because we are quite in the beginning, but it's definitely years and years.
Mm-hmm.
It's definitely not going really fast, because it's also when you're moving through even from the pilot scale, then there is like a commercialization and patents about the materials, but you need to push through to the national or worldwide legislation. That's mean it's a quite complicated way and route how you can from the lab reach the industrial scale and actually a wider application. But yeah, it's really important just to deal with these things and get some ideas then how to react in these all emerging problems in the environment.
Mm-hmm. For sure. Well, that brings me to the last question for today, which is, aside from like utilizing plastic as adsorbents, which is what your research is mainly focused on, what are some other like promising areas that you think people should be working on to tackle the plastic pollution problem? So this could be like waste management or whatever you think is going to be a really effective solution in the coming years.
Yes, I think the first thing is to produce and use less plastic. That is something for the normal people. We can do it. For example, if more people realize how serious the problem is, they may pay more attention to for example, the waste classification, or maybe more of them going to join the beach cleanup activities, or just simply use cloth bags instead of plastic bags for shopping. And for scientists and researchers, I think we can develop some more biodegradable plastic and implement them in more areas. Well, currently we don't have a lot of options for biodegradable plastic, and many of them cannot be used in large scale. So we want to maybe it is good to develop some environmental friendly plastic in the concept of green chemistry.
Mm-hmm.
And this last thing, I think I saw some news that said big companies like Adidas, they already started to use the recycled plastic as materials to produce the product, such as shoes, clothes, or some little toys for decoration. And that leads to another way, how we can recycle the plastic in different fields and how we can recycle them more efficiently.
Mm-hmm. For sure. Anything to add, Dr. Pap?
No, I'm quite happy with Huiyi's answers.
All right. Well, thank you so much to the two of you for taking the time out of your day to join me on this podcast and for sharing your thoughts on this issue.
You're welcome.
You're much welcome.